Hello students, welcome to the class. Today we will see the JEE PYQs part 3 of the NCERT chapter 2 structure of atom. Disclaimer, the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using generative AI, which is experimental. So here is your first question. It was asked in 2005 for 1 marks. The number of radial nodes in 3s and 2p respectively are. So your time to solve this question starts now. Your time is up. So this is an easy one. You just have to look for the formula, which is n minus L minus 1. For the 3s and 2p, you must know the n and L value. If you do this calculation for both the subshells, you will get your radial nodes as 2 and 0, which is option number A. How we'll do it? As I said you, this was the formula n minus L minus 1. What will be the number of nodes, radial nodes in case of 3s? So since it is a third shell, we will take the n value as 2. For the s orbital or the s subshell, we will take the L value as 0. And if you do the calculation, 3 minus 1, it will give you 2. What about the 2p? So in the case of 2p, the number of nodes would be 2 minus 1 minus 1. Again, that same concept here also. We will take the second shell. Therefore, the n value will be 2. For the p subshell, the L value is 1. And if you do the calculation, you will get your answer as 0. I hope this is clear to all of you. Moving on to the next question. So this was asked in 2002 for 3 marks. If the nitrogen atom had electronic configuration 1s7, it would have energy lower than that of the normal ground state 1s2, 2s2, 2p3, because the electron would be closer to the nucleus. Yet 1s7 is not observed because it violates. So there are a set of rules given. The first is the Heisenberg uncertainty principle, which is option number A. B, Hund's rule. C, Pauli's exclusion principle. And D, the Bose postulate for the stationary orbits. So if I try to explain this question, it is saying that since your electron can be closer in case of 1s7, so if you take the case of 1s7, then what would be the radius? It would be, of course, lower than the 2s and 2p, right? It would be lower than the 2s and 2p if it is a 1s subshell, because the distance will be less. And if it is closer to the nucleus, then the atom would be more stable. But it is seen that your electron cannot go into an orbital which is already having 2 electrons. It goes to the next one. So with this, your time to start solve this question starts. So what would be the correct answer? The correct answer for this would be the Pauli exclusion principle. Why I am saying this? Because if you look at 1s7, then if we take this case of 1s7, then what would be the quantum numbers, the value of 4 quantum numbers related to these 7 electrons. Suppose I am taking it for the first electron of the 1s, second, third and fourth. Then I am writing this n value, L value, ML value and MS value. For the first electron, the n value will be, if it is lying in the 1s, it will be 1 for all of this, because all are lying in the first shell. Okay, all are lying in the first shell. What about the second one? The L value, it will be 0 for all. Okay, so this will be 0 for all of this. Very good. What is the ML value? So s orbital can have only one type of value, which is 0 in case of the magnetic quantum number. Therefore, this value will be also 0. Right? So I am not putting up the same thing for the 5, 6 and 7. They will have the same thing. Now, if you put up the magnetic quantum number, spin quantum number, then first can have the plus half. Obviously, the second will have the minus half, to follow the Pauli exclusion principle that no two electrons can have the same set of all 4 quantum numbers. So they both are having the spin quantum number different. But what about the third one? There is no possibility left for the spin quantum number because we have used the plus half and the minus half. As a result of it, the electron cannot go into 1s further. So it goes to the higher energy state, which is 2s. I guess it is clear to all of you. So the same thing can be applied to the third electron, the fourth and up till the 7th one. Moving on to the next question. The quantum numbers plus half and minus half for the electron spin represents, your options are rotation of the electron in clockwise and anti-clockwise direction respectively, B, rotation of the electron in anti-clockwise and clockwise direction respectively, option C, magnetic movement of the electron pointing up and down respectively, option D, two quantum mechanical spin states have no classical analog. Now this one is a very good one, okay, and I have already discussed about this spin quantum number in detail, that it has no physical significance at all. It is an intrinsic property. So your time to solve this question starts now. If you are well aware about the theory class, you will be easily able to give the answer of this. So I guess you will be surprised by the answer in this question. So the correct option will be option number D, right? That two quantum mechanical spin states are being shown by the plus half and minus half, and there is no classical analog. Now what is the meaning of this classical analog? This is important to understand. So when I say something like, if you are telling about someone's character, right? So it is intrinsic to that person, means you can't look at a person and just by looking at him, you can tell about his or her character. Yes, you can tell about his height, that if he is short or tall, okay, if he is long or tall, you can tell that thing, but you can't judge his character just by looking at him. So we will say that this character is intrinsic to that person and his height is extrinsic to that person, and it has no classical analog, means there is no physical I would say enhancement of the character. You can't see character moving here and there, so it is within that person. There is no classical analog. Similar to that, your electron's spin also have no physical I would say physical appearance or classical analog. It is intrinsic to that electron, right? You will not see an electron revolving on its axis, okay? It will not revolve like a top or like a planet. Now it is intrinsic, but still it is a spin, so that will be represented by the two quantum mechanical spin states plus half and minus half. Further, if it is spinning intrinsically, then it will have a spin angular momentum also. But again, that spin angular momentum has nothing to do with the classical thing. So any doubt in this question? The number of nodal plane in a px orbital is? We are talking about the nodal plane. Option A 1, option B 2, option C 3 and option D 0. Your time to solve this question starts now. It's an easy one, so I am giving you a lesser time. Your time is up. The correct answer will be 1. So since it is a px orbital, there is only one nodal plane that is possible, which is represented here. So you know the shape of the p orbital is a dumbbell one. So between both these dumbbells, you can see that there is a plane that is passing between them. So that plane is said to be the nodal plane. Okay. Now there can be a confusion in your mind that why are we not considering the radial nodes in the nodal plane? Okay, because it is also a node, but your radial nodes is not a planar one, it is a spherical one. Okay, so this is very important to understand. This node which we are considering here, they are angular nodes. Okay, and for one angular node we have one nodal plane. So this is your angular node in the between, that is being represented with the help of this nodal plane. But the radial node is a spherical one. We will see it, how it is spherical. How is it planar? You can see it. How the angular node is planar, you can see it very clear from here. But how the radial node is spherical, we will see it in the upcoming questions. I guess this thing is clear to all of you, that what is nodal plane and why it is not applicable to the radial nodes, or why radial nodes do not represent the nodal plane. Okay, moving on to the next question. The electrons identified by the quantum numbers n and l, which values are given here. N is equals to 4, L is equals to 1, 4 and 0, 3 and 2, 3 and 1. Now you have to arrange all of this in the increasing order of energy. So your time to solve this question starts now. So your time is up. What will be the correct answer? Let us see. So this was asked in the 1992 for 2 marks. So if we try to arrange all of this with the help of n plus n rule, you will get the order as 4, 2, 3 and 1. So how we'll solve it? It's the easier one. First we will find the n plus l value for each of them. In case they have same n plus l value, then the one having the higher value of n will have the higher energy. So for the first case, it will be a 4p orbital, of course. For the second case, the 4s. The third case, it will be 3d, and the fourth case, it will be 3p. What is the n plus l value for this? It is 5. For the second, it is 4. For third, again it is 5. And for the fourth, again it is 4. So I can write here that n plus l value for the 4p and for the third one is 5, whereas for the second and the fourth it is 4. But what will happen? Since your 3p has a lower n value, it will have a lower energy. So 3p will have the lowest energy because it has both n plus l value and n value lesser. Then will come the second one, Okay, so fourth one, then the second one, then the third one because it has a lower n value, although it has n plus l value same as the first one, and lastly the first option. Therefore, according to the above principle, this is the order that we will get. Moving on to the next question. For a d electron, the orbital angular momentum is, options are A, root under 6 h by 2 pi, B, root 2 h by 2 pi, C, h by 2 pi, and D, 2h by 2 pi. Your time to solve this question starts now. So this was asked in 1997 for 1 marks. So there is a formula which we will talk about. Those who know the answer, they can write it by yourself. Okay, your time is up. Let us move to the correct answer. The correct answer will be root 6 h by 2 pi. So there is a formula for calculating the orbital angular momentum, which is given by root under L into L plus 1 h by 2 pi. Now there can be written h cut in place of h by 2 pi. So you don't have to worry in case h cut is written in place of this whole h by 2 pi. Put the value of L for the d electron. For the d electron it will be 2. So 2 into 2 plus 1, that is 2 multiplied by 3 will give you 6. Okay. So I am representing this orbital angular momentum with L here. Similarly, you can calculate the spin angular momentum also. The formula for the spin angular momentum will be S is equals to root under S into S plus 1 h by 2 pi, where S is the total spin. Now how do we apply it? Suppose there is a subshell which is P, and in that P subshell 4 electrons are there. So what will be the total spin in this case? If you calculate it, for the first you will add the plus half. You will add the all plus half. So plus half, and plus half, as 3 electrons are having a plus half spin state. Now the fourth is having a minus half spin state, which is down arrow. Now add all of this. You will get your total spin as 1. Okay. Now put this value of 1 here and you will get your spin angular momentum for this configuration, which is P4, in terms of h by 2 pi. Okay. Now your possibility of 2 spins are there for electron. Only 2 possibilities are there, which are plus half and minus half. So they are just the simple manifestation of the, you can say, the superposition, right? But there are possibilities of multiple spin states, but not for electrons, for other particles, right? So fundamentally I am trying to say that your electron can only have 2 spin state, which are plus half and minus half, and that's all. Now this is a question which was asked in 2016 in the JEE Advanced. P is the probability of finding the electron, 1s electron of hydrogen atom in a spherical shell of infinitesimal thickness dr at a distance r from the nucleus. The volume of this shell is given by 4 pi r square dr. The qualitative sketch of the dependence of P on R is. So you have some time to solve this question. Your time starts now. Now this question looks a longer one. If you are aware about the probability density and the probability, you will be able to solve it very easily. I will try to explain it in the best way possible, but you should know the boundary surface diagram and the probability density diagram for that. Okay, your time is up. So, what will be the correct answer? It will be option number C. Let us see how we can solve it. So, if you look at the graph, you can physically manifest that graph according to the 1s of subshell. How? Let us see. So, if you see it, you can see that here at the nucleus, which is represented by 0, it is having the minimum probability. Now, as we move away from the nucleus, this probability will go on increasing, and after reaching a maxima, this probability goes down again to the minima, but it never touches 0. The electronic configuration of an element is 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. This represents the first excited state, B ground state, C cationic form, or D anionic form. Your time to solve this question starts now. Okay, your time is up. So the correct answer will be the ground state. So those who have done a mistake, no problem. Just try to think over it. We have seen this thing. So whenever there is an involvement of d orbital, there is a greater significance of the half-filled orbital. Okay. So instead of fulfilling this d orbital fully, what we have done, we have moved the 6th electron, which should come to the d, but it is coming to the 4s. Why? Because the half-filled d orbital are very much stable, especially the d orbital, because it has a higher chance of exchanging its position. Therefore, it will have more exchange energy. Okay, and hence this is a ground state and not excited one. So what we can say, that it is an ground state electronic configuration of chromium. Then moving on to the next question. The electromagnetic radiation with maximum wavelength is. So this was asked in the 1985 for 1 marks. It's an easy one. Options are A, the ultraviolet, B, the radio wave, C, the X-rays, and D, the infrared. You have 10 seconds to solve this question. Your time starts now. So this is about the electromagnetic spectrum. Now those who don't remember this order, let me give you an easy way to remember it. You just have to remember the farthest one and the lowest one. You must have heard about the gamma rays. You know it, it's very powerful. You must have heard this in the comics also and in the cartoons also. So it has a very high power. You know it. If it has a high power, means high energy, that means minimum wavelength. So put this gamma in the minimum. So I am giving you a mnemonic to remember it. Gamma rays. Now, second thing, you know that visible will always be in the middle. So this you can remember it. So this thing you should remember. Now, in the visible, we start from the violet, go to the red. Between this we have Vibgyor. So R has the longest wavelength, which is red. So after red, it will be infrared, right? Okay, it will be infrared. Similarly, here it is written violet, then this will be ultraviolet. Ultraviolet. So now you know most of the spectrum without even remembering it. Again, energy is highest for gamma rays, so minimum wavelength. Right? The visible one, visible is starting from VIBGYOR. So V is violet and ending at the red, R. So for red, write infrared on the right, and for violet, write ultraviolet on the left. Now 3 more are left. So this thing is called as the microwave. Lastly, your radio waves are the longer one. So it is radio used for the long communication. So it is of the longest wavelength. And this is your X-rays. Okay, just try to remember this with the help of this mnemonic. Now we have further classification of radio into short radio waves and long radio waves. Okay. Then moving on to the answer. If this is true, then which will have the maximum wavelength? Yes, longest wavelength with the lowest energy. So it is obviously from the formula which is E is equals to hc by lambda. So energy is inversely proportional to lambda. Correct answer will be the radio wave. So the order of wavelength can be written as X-rays, ultraviolet, infrared, and the radio wave. Where the radio wave has the maximum wavelength, minimum energy, whereas the X-rays has the minimum wavelength and the highest energy in the given options. Then we have our next question. The increasing order for the value of E by M for electron, proton, neutron, and alpha particle is. Now this one is a good one to solve. You just have to be clear about the mass and the charge. Just try to take the relative charges and the relative masses rather than the absolute one. So that will be easy to solve. Your time starts now. Okay, so this was asked in 1984 for 1 marks. The correct answer will be option D. How will do it? So first of all, let us consider this thing for the alpha particle. They are made up of 2 protons. Okay, they are made up of 2 protons and they do have a charge of 2 positive. So what will be the E by M ratio for the alpha particle? What will be the E by M ratio for alpha particle? It will be 1, right? The value of E by M ratio for the alpha particle will be 1. Then what will be the ratio of E by M for the proton and electron? So for the proton, the E by M ratio will be again 1. Okay, but it has a slightly less mass, right? So for the helium 2 plus, it will not be 1. Okay, it will not be 1 because the mass is higher. But what about the electron? It has a negligible mass, so it will be 0. Now let us try to calculate for each of this. First, we'll take it for the helium 2 plus. What are the number of protons plus neutrons? So protons plus neutrons is equals to 4 because it is the mass number of the helium plus. This is the mass number of the helium plus. So mass is taken as 4. Again, remember it is a relative mass. What is the charge? 2 plus. So charge is 2. Therefore, E by M ratio, which is charge is to mass ratio, will be 2 by 4, that is 1 by 2. Then we will calculate it for the proton. Okay, so proton we can take it simply H plus. So H plus is what? A proton. It has no neutrons, so it is simply a proton. If it is a single proton, then the mass number will be what? Mass number will be 1, which is your M. What will be the charge? Charge will be also 1. Therefore, E by M ratio will be 1 in this case. And what about the electron? Electron has a charge of again 1. It is -1, but we will not take the sign, we will only take the magnitude. What about the m? In relative to the mass of proton and all, it has a negligible mass, so we take it as 0. Therefore, E by m ratio will be infinite for case of electron. Okay, it will be infinite for the case of electron, and hence we take it the largest one. We take it as the largest one. So first comes the neutron, then comes your alpha particle, and then comes your electron. I guess it is clear to all of you how we have solved it. Now where there is one more thing, which is neutron. Okay, so this will be proton first because it is 1, then here will be alpha. Alpha is half. If we take it for the neutron, then the neutron mass is 0 and the charge, neutron mass is 1 and the charge is what? Charge will be 0. So 0 by 1 will give you 0. Therefore, neutron will be in the first one. So anyone has a doubt in this? How I have got this order? So if you have a doubt, you can ask it right now. Okay. So this is the calculation of the proton. This is the calculation of your alpha particle. This is the calculation of your neutron, and this one is for the electron. Okay, moving on to the next one. The number of neutrons in the dye-positive zinc ion with mass number 70 is. Options are 34, 36, 38 and 40. Your time to solve this question starts now. Okay, your time is up. So the number of neutrons in dye-positive zinc ion with mass number 70 will be option number D, which is 40. How do we solve it? It's an easy one to do. So the number of neutrons in zinc ion will be mass number minus the atomic number. So mass number is already given. Atomic number of zinc is 30. That gives you your what? Number of neutrons. So this was all from the PYQ section. Okay, so this is your first question. One would expect protons to have very large charge, ionization potential, hydration energy or radius. So what will be the correct answer for this question? Anyone? So hydration energy, radius, ionization potential or charge. So I am giving you 10 seconds to solve this. So it has a large what? Ionization potential. Okay, it is very difficult to remove a proton from a given nucleus. Next question. The ionization of hydrogen atom would give rise to. So if you are considering a hydrogen atom, it consists of one electron and one proton. If you remove the electron, what will be left in it? Only proton will be left in it. So it will give rise to the proton. We have already talked about it right now. According to the law of photochemical equivalence, the energy absorbed is given by, so we have the value of H here, we have the value of C given here, and Na also given. So what will be the correct answer? How do we calculate this? So energy you have to calculate in terms of energies per mole. Now, if you want to calculate energy with this, you have to use the H into C. Okay, you will calculate your HC by lambda here. But we have been given with the value of C, we are given with the value of H. What about the lambda? Any guesses? What will be the correct answer? You have to calculate in terms of per mole. Okay, so you will take your HC here. So 6.627 into 10 to the power minus 27 multiplied by the C, 3 into 10 to the power 8. But we will write it as centimeter per second. So all of these things are given in the required unit because we want it in the term of energies per mole by lambda. So this is the energy of one proton. Now for 1 mole, we will we will divide with this 1 by Na. Okay, we will divide it with the Na. Just do this calculation and you will get your answer as, so 6.62 multiplied by 3. 6.62 multiplied by 3 will give you, it will give you 1196, okay, approximately. So whether it will be 16 or 8, it will be 8, I guess. Okay, so you can calculate by yourself. Moving on to the next one. So in this question, which one is the wrong statement? The uncertainty principle is delta E multiplied by the delta T greater than or equals to H by 4 pi. So now this question here includes a new form of the uncertainty principle where we don't take the momentum and position. Instead of that, we take the energy and time. So energy and time, they are also not calculational at the same time for a given electron. So this is true. Second thing, the half-filled and full-filled orbital have a greater stability due to the extra exchange energy, greater symmetry and more balanced arrangement. Yes, this is also true. What about the third statement? The energy of 2s orbital is less than that of 2p for hydrogen-like atom. So this is false. We have already seen that 2s and 2p belong to the same shell. Therefore, they will have the same energy. What about the fourth one? The de Broglie wavelength is given by lambda is equals to h by mv, where m is the mass of the particle, v is the group velocity of the particle. So this is also true. Therefore, the incorrect statement will be C. Moving on to the next one. A 0.66 kilograms ball is moving with a speed of 100 meter per second. The associated wavelength would be, so you just have to calculate the lambda. H is given 6.6 into 10 to the power minus 34 by mass into velocity. Mass is given as 0.66 and velocity is 100 meter per second. So this will be cancelled out and it will be 1 times of this. Therefore 1 into 10 to the power minus 35, which will be option number D. this. Okay. Moving on to the next one. The measurement of the electron position if associated. So let us look at option number A of question number 5 once again. So correct option will be 1 into 10 to the power minus 35, I guess. So I am calculating it once again. 6.6 into 10 to the power minus 34 divided by m into v. So mass is 0.66 multiplied by 100. Okay. So if you remove this decimal, this 100 will get cancelled out, and 66 multiplied by 0.1 will give you 6.6. Now 0.1 multiplied by 10 to the power minus 34 will give you 1 into 10 to the power minus 35. So correct answer will be option number D. Right? Is it clear now why option D is correct? Okay, so anyone has a doubt now? Moving on to the next one. The measurement of the electron's position if associated with the uncertainty moment, which is equals to 1 into 10 to the power minus 18 gram centimeter per second. Now the uncertainty in electron's velocity will be, the mass of electron is given. So we are already given with what? We are given with this uncertainty in momentum. So m delta v is given. It is equals to 1 into 10 to the power minus 18. Now we have to calculate the uncertainty in velocity. So here is a very important point here. What is given? Uncertainty in momentum is given. So this value is given. But we know that mass has no uncertainty. So we will take this mass out of this, and then we will get m delta v 1 into 10 to the power minus 18. Right? Further, the mass is also mentioned. It is given as 1 into 10 to the power minus 18 gram centimeter per second divided by the mass 9 into 10 to the power minus 28. Okay. So just calculate this and you will get your uncertainty in electron's velocity. Moving on to the next question. So I am putting option D as the correct one. So our next question is, if uncertainty in position and momentum are equal, then uncertainty in velocity will be. So this is a very good one to solve. So it is written that you have to take both the position and momentum uncertainty as same. So let us consider that the uncertainty in position is equals to A, and this will be also the uncertainty in the momentum, which is delta P. Now delta X multiplied by delta P is equals to H by what? H by 4 pi. Okay. If we substitute A in place of this both, you will get H by 4 pi equals to A square, or A is equals to root under H by pi multiplied by 1 by 2. But we are cautious about the velocity. Okay, we are cautious about the velocity. So instead of this delta P, we can write it what? We can write here mass into delta V. Now the uncertainty in momentum will be equals to the uncertainty in the velocity. So remember this, whatever with the uncertainty in momentum, that will be same for the velocity also. If this is true, then what we can write further? We can write here delta X into delta V multiplied by M. Okay, delta X into delta V multiplied by M will give you this, which is h by 4 pi. Okay, no, we will not take the velocity because this uncertainty is related to the momentum. Okay, it is related to the momentum and not to the velocity. Okay, so this will give you h by 4 pi, root under h by 4 pi. So therefore the correct answer will be 1, I guess. So there is a confusion in this. So we'll see to this in the next class if possible. Now I'm leaving the rest of the DPPs for you. This was all from my side. Thank you.